Welcome to Joe's Bench 506. On the bench this morning, I have a Pioneer SX-828. The reason it's on the bench, it was recently bought from a local guy from my town, and he called me up and he says it was working, and all of a sudden it started to blow fuses while he was, I believe he told me that he was playing with the mode switch. I'm not sure if that's related or not, but anyways, it blew the fuse. He changed the fuse and it blew again. So we have a short. So we do have an issue with the amplifier. It will not power on because of a blown fuse. So we're here to test this. I'm going to put it through my dim bulb and we're going to try to power this on. And it's not powering on. So we have an issue. Okay, so what we're going to do, unplug this. We'll take the cover off, I'll replace the fuse, and I'll put it through the dim bulb and see. And then we'll continue on from there. I think this is going to be a good project, and we're going to get to work. On this cover, it's covered. Okay. These are my outputs here. So we are going to take these covers off. These are my outputs. According to this is not open. It's this one that's open. So the main fuse here, this is still good. Just need to change this one. The fuse has been changed. Put a brand new fuse in. It was a 3-amp fuse. So the thing that I don't want to do is I don't want to blow this fuse again by plugging this in and have the same results. This is not getting ahead of ourselves. So we're going to put this through protection mode. Okay, and we'll see what actually is happening. And under my dim bulb, see, I've got a dead short here. I'm going to check the output transistors. See if these outputs are good. So the outputs, I do believe it's the left side. They're short, and that's why it was blowing fuse. And I'll show you that in a little bit. I've already found the issue that was blowing the fuses are the output transistors. Okay, I didn't even have to plug it in. You just have to test those outputs, and you can test those very easily. See right here, these are my outputs out here, okay? and the left channel seems to be short on those. And I'll show you what I've done. So I have a good junction here. Now this would be there's a good junction. This is the NPN. And this is the PNP. So the right channel is okay. I'm going to move down. Check this out. Major short here. There's the short. Okay. Sorry, it has to go on top. This is short. So we have an issue with the output transistors. My next step will be to take the power amp board out of there, and then I'll expose the TO3 transistor, and we'll go from there. Okay, so I'm going to show you what I'm going to do with this. This is the power amp board here with the heat sink, and the outputs are right behind here. So all I had to do is unscrew 2 screws there, and the 2 screws over here, and now this is loose. I'm going to be able to take that out of there. So the left channel is where my issue is, but even though there's nothing wrong with these outputs here, I will have to replace all 4 of them just so we can have a good match to this. But while I was waiting for his answer, I changed all the capacitors. It was only 2, 3, 4, 5, 6, 7, 8. There was 8 capacitors on the power amp board, and easy enough to get at. He wants me to change those, and I did. Replace them with brand new ones. And of course, something else here that I've noticed. Give you some light, and I just want to show you something right here. Right there, this is a resistor, and it's a 10 ohm resistor, and it's really dark in the center, and if I'm touching it, it's kind of peeling off. It's breaking into pieces. So I think I will change, even though the value of this is still good. I found that resistor has taken on some heat, so maybe might be a good idea to replace it. So I'm going to replace that resistor. It's a 10 ohm resistor, and I'll probably do the one on the other side as well. Here's a here. I'm going to get this thing back to operational again. These ones were short. Now I've taken those 2 transistors out of there, and those were the ones proving short. Remember these? Now I've got no transistors there. Wanting to bet money that if I turn this on, my lamps are going to go off, and the relay should kick in. If that was the only issue that I was having with this, the relay should actually kick in. Watch this. Here we go. See? And the relays clicked in. So the only issue was the 2 transistor. They're out of there now. My short is gone. Relay has kicked in. So we're going to power this off again. I just wanted to prove to you guys that But you know what? Your multimeter was testing short, and it was actually short. Okay, I proved it to you guys by putting it through the dim bulb. Once the output transistors were out of there, my short was gone and the relay kicked in. So the only issue was left output transistors. But like I said, we're going to replace both channels. So we're not just going to replace one side, we'll replace all four of them. And while I'm doing this, change all the capacitors on this power amp board as well. It's going to be back operational in no time. Okay, so let's continue on. Okay, so this is what this is going to look like. Got the new output transistors. I got to put the screws back on. Put in some new thermal paste in it. And it looks pretty good. Just want to make sure that everything is all set here. And then we'll try this out. Pretty confident that it's going to work. You know, I try to avoid any complications on this, okay? So, clean it out a little bit. I'll make it look okay. Check if I have any continuity. There, that should be good. We're good to go with this. Now, I'm kind of curious, aren't you? This is ready to be powered back on. Okay, so under protection again, I've got the output transistors all settled in, screwed in, put some new thermal paste in it, and I've got that plastic. I replaced these insulation cap that goes in between the heatsink and the output transistors. Those are brand new as well. Okay, so now, always curious of my work, always, all the time. Like if I repair one section, I want to see if it's actually working. So right now I'm under insulation. I have this foam, an inch thick. Nothing is touching. I feel really comfortable about this. And I just want to see if this is going to power on through my dim bulb. Remember, I had a dead short on the left, eh? So if my dim bulb does not light up and my relay clicks in. So let's try it, okay? Let's do it. Oh, the relay clicked in. Perfect. So now we know the issue was the output transistor. Again, I knew that it was, but it's always nice to show you guys that, you know, as you advance or you're repairing stuff, it's always nice to prove to yourself that, you know, you're on the right track, eh? So, bango. We're gonna power this off now. And you know what? I'm ready to put this back and go from there. Okay guys, I wanted to show you guys what I have. Check out the TO3 transistor that I replaced for them. I don't know if you can see the number, but replace them with MJ21195 and the 196. Okay, that's what I've replaced them with, and I think they're going to work perfect with this. I'm going to put this board back in place and then we'll be able to test it. Okay, here we go. So now this board is all done. I've changed the outputs, all the capacitors that were on there, two 10 ohm resistors. I've changed those. And now we're ready to continue on to the next board. I think I'll do this one. This one's easy enough. Maybe I'll get this one exposed, see what's underneath here. This is the phono board. I'll check the capacitors on this. Okay, I've taken this board out of there. This one, I've only found one of them. This one was high in ESR. That's the only one. And then at the same time, the power supply board was easy to take off, so I did. And I'm glad I did. I'll show you what I found on the power supply. This was already worked on before. This resistor here has been changed. But I'm going to need to retouch this. This is something that could be causing some issues later on. Yeah, that's a little better. And this dries out really quick. This is alcohol. There, cut that off. This board has been repaired to my liking. I like this. Just wanted to show you. This is a real dark spot here, and this was from the power supply board. They've changed this resistor for some reason. There's a transistor there as well. Let's check that transistor. This 1000 microfarad capacitor on the power amp board was actually working half. This is a filter for the power amp board, and I believe that might have been the cause that gave us an issue for the output transistors. Okay guys, I just wanted to explain to you a bit about that capacitor on the power supply that I found that was bad. This is the actual schematic for the 828, and the capacitor that I found was bad was the C5. It was 1,000 microfarad at 10 volt, 1,000 microfarad, and I clocked it at 400 microfarad. So it wasn't really filtering what it was supposed to filter coming out of this transformer here, going through my rectifier there, and then filters out the negative. I guess it's a negative 44 and 45 here, but that is a direct hit. If you follow this red line here that I've drawn, goes directly into my power amp, and this is where the two output transistors that I've replaced, those were the two that were short, and that was a direct hit. So, you know, I'm not so sure if I would have just changed the issue that I was having was this was short. But I mean, if I wouldn't have checked further or every single circuit board on this for, you know, leaky capacitors, I might have missed this. And so it might have happened again, you know, the next time around. I was kind of glad that I found it. And usually if your output do go short, it originated from somewhere. And in this case, I believe that this was the culprit right there. So if you are working on an 828 receiver, please check that capacitor on that power supply. And that capacitor is C5. Okay. But anyways, we caught it on time. We're putting this back together. All these boards here that you see on the bottom part of this receiver has been touched. Completely changed all the capacitors on the power amp board where my issue was originally. This is the phono stage here. I didn't have to change any capacitors on this. I've changed only one capacitor on this board here. There was an issue that I've showed you on the power supply board. When they soldered it, it wasn't really soldered that great. So anyways, I repaired it. I'm ready to test this out, see if this is actually going to turn on after I've changed the output transistors. And we'll go on to the next step. Right now, it's working perfectly. I've checked all the lamps on here. The lamps are all working accordingly. I had an issue with the power. I had a major issue with the power switch. When I pulled this knob off, the whole shaft came right out. Some parts, you know, came loose, and I wasn't able to work it again until I put in several hours on this power switch. So it took me a while to figure out how it works, because on this power switch, I've got the power on and off switch, and then I control the speakers with it. Speaker A, off speaker A, B, and C. So there was a lot of combination. It's like a combination lock, man. You just gotta make sure that everything is all in line. And then of course you have lamps here, right? You have the A lamp, B lamp, and C lamp. So if the speaker A is working, well, the A lamp is on, not the B lamp. So I'm telling you, it's a headache. So if you ever run into this and with an issue with that switch, don't be calling me, man. You can send it to Trevor's Bench. Is the only person that I know. Love working on these. He works on these switch with a big smile. Let me tell you, I didn't have a smile when I was working on this. It's just that to me is casse-tête. You know, gives me a big headache. So I got it going, and I am not touching it again. Other than that, this thing is going to be Awesome. I've only got about another hour to put in here, and then I'm going to be able to test the bias. I will have to test the bias on this. It's an absolute must because I've changed the output transistors, okay? But that's going to be a lot of fun. Be able to switch. Okay, so we're moving along. All in all, this is going to be in a really nice receiver. The owner of this is he's retired and he likes this stuff. He buys Marantz and he changes them over, and he just it's just like he likes the receiver. He likes to try them out, type of thing. But anyways, I'm gonna shut up and I'm gonna get to work. Okay, so let's continue on with this. I need to get some ties to tie all this. I had to take this all apart for that damn switch that I had. I lost about 3 hours on that switch, but and that's why if you're bringing this to a technician, you know, he's going to charge you a lot for labor because it's a lot of work. This is a fresh, brand new morning, and I'm on the bench with this Pioneer SX-828. I've replaced the output transistors. I've checked all the capacitors, which I've changed quite a bit. Right here, these are the outputs that I changed. All these capacitors, there's a fuse. And also I had to change the 10 ohm resistor right there. Okay. I wanted to show you guys the transistor that was short. This is the 2SC1080. Got it hooked up on this little machine here I've got here, and this is what I was testing. Just tested it as a resistor, and then we'll try the other one. And this one was the 2SA680. And this one was also short. They're both on the same channel. And here's this one. It's checking in as a resistor. So we had to replace them. It was good to check those. Here's the other channel. The other channel I was testing, okay. There we go. This was this is the NPN. So yeah, this little rig is nice to have around just to test your components and stuff. But anyways, show you guys that these transistors were short, along with a lot of stuff that I found was wrong with this receiver. I'm not really sure why the output transistor short, but obviously there was a short somewhere, and I'm almost willing to bet that this capacitor 1000 at 10 volts was into the power supply, and I had a lot of issues on the power supply. All these came from the power supply. This one here is a filter on the power supply for the power amp. And I believe this was causing a lot of issue, and it might have just created a short enough to shorted the output transistors. That I'm not sure. I'm just speculating, I guess. And this was also from the power supply. There was a lot of issues on the power supplies, and all the other ones were coming from different boards. Also, I changed. I don't know if you guys remember, but I did change these two resistors. the value of them were still good, but they got really dark in the center, and I was kind of afraid. And as you were touching them, you can tell it was coming apart. Eh? The coating was coming off of it, so best bet is to change those. And I replaced it with a new fuse, and it's working great. This was the fuse. So where am I? I'm at the point now that I've turned it on, and I didn't have to use the dim bulb. I was confident enough that I could just use a regular outlet, and it's on the regular outlet. My dim bulb is off and the power is on this thing. Now what's left to do is whenever you change the output transistors, it's an absolute must. You need to check your bias. And I was online this morning. I took about a half an hour. This is what I was able to get online. I do have the schematic for this, but it doesn't say much about the bias for some reason. Usually Pioneer is bang on with this, but other people have done the same thing as I have done. My bias should be set to 20 millivolts. I'm not sure what it's set at now, but anyways, I need to go on pin 17 and 11 on the left and 12 and 18 on the right. Okay, so this is the left and this is the right. So we'll do, it doesn't really matter, we can start off with the left channel maybe, because that's the one that I had to replace the output. So I'll hook up. One is 11 and 17. Here's 11. And there's my 17. There. Let's measure the millivolts, and my millivolts is set to 12. Here, I'll give you a closer look here of what I'm doing. And hopefully you'll be able to see my multimeter. Multimeter is measuring millivolts hooked up to the power amp. Pin 12 and 18 is the left channel, and I'm reading 12.9, and I'm going to be setting this to 20 millivolts. Okay, and I'll flip this around just like this, and here's my pot way down there. You know what, I don't like this at all, so we'll have to figure out something here. I'll use this long screwdriver. I have to go deep in here, right? Okay. There's the pot right there. And I feel that I gotta go pretty deep in that. I don't want to be touching anything other than the trimmer pot. So let's go down to the trimmer pot. There we go. Now check out the multimeter. I'm going to set this to 20 millivolts. .6. Would you guys be okay with that? 20.5 with that. 20.4. I'm okay with that. Okay, so that was one channel. Let's do the other channel. Here's the other channel. The other channel should be 12 and 18. There's 12, and here's 18. There, and we both have the same, look at that. The other one was 12 point something, and this one is 12. Now, I've never ever touched this yet, eh? The other trimmer pot, and we'll bring this up to 12, 20. .6, 20.5. You guys okay with that? 27. Let's go back and touch it just a little bit. .4, 20.3. That's perfect. So my bias is set to 20 millivolts on each channel. I'm pretty good with that. Let's try for some DC voltage. I'll try to get my pinouts here. There's 1 and 2. And I have 60 millivolts. We can correct that. Certainly will. And these are the trimmer pods on this side. So there's a trimmer pod right up there. I don't know if you guys can see this, but the other way. .26. There, I'm below 10. I'm happy with that. Okay, let's try the other channel. There's the other channel. Let's check it out. That one there is even better. I don't even have to touch that one, but if I had to, it would be this one. This trimmer pod right in there. Okay. So we're all set with the biased, and we're all set with the DC voltage, with no DC voltage. So I'm pretty happy with this. My next step now is I think I'm going to put the front plate back together. Okay, here we goes. There we go. So the bottom plate is back on. Put the knobs back in there. Took me a little while to put all these buttons back in. Some of them I needed to glue back on. This one, the center of it was just falling off, so I had to glue that. but everything seems to be working a-okay. It looks nice, actually. Now I'm going to hook up some speakers to this and I'm going to do a sound test. So we're aiming for 54 watts per channel with this Pioneer SX-828. Are we going to get that? We're about to find out. Let's do it. Hooked up on the scope. I've got it on regular outlet. Let's power this on. Let's see what we're gonna get with this. Auxiliary lamp, speaker A. Check the volume here. It's make sure that it's off. Here we go. There's your frequency. I'll set this over here. And the fun begins, okay? I'm gonna get you guys closer. So I'll start cranking this up a little bit, okay? So you can watch the scope. And there it is. See this? I'm at 20. I have just a little bit of distortion, but not even enough to say. I'm at 21.6. Both channels are equal. So at 21 RMS, I'll add this up for you guys, but I'm gonna kick this back down. So 21.6 RMS under an 8 ohm load. You divide that by 8. That's 58.3 watts per channel under an 8 ohm load. And I have 0 distortion. This thing was wide open. Wide open under an 8 ohm load. Jesus. This is crazy. Okay, if it's all plugged in, let's see what it sounds like. Okay guys, hope you enjoy this video. It was a fun project, and hope we were able to learn a little bit, you know, by watching me or following me. And thumbs up if you like the video, and subscribe to my channel. I would really appreciate it. Next on the bench is going to be a Pioneer SX-3600. It's just here for a service. I don't think there's anything wrong with it, but make a video out of it. Okay.